Okay, so in this video and the next one, we want to look at something called rationalizing the denominator. So when we write fractions that involve surds, it's conventional to express the denominator as a rational number, i.e. not to have surds in the denominator. Now there's no real reason for this, it's just someone decided that was the convention, and so that's the convention. In the same way that someone at some point decided that we should start sentences with capital letters, and now that's the convention and we all do it. Someone decided that it's not very nice to have irrational numbers or surds in the denominator. Now, to be fair, it does make it easier if you are working with lots of fractions and you're having to combine fractions together and adding and subtracting and you need common denominators. It does make it much easier if there is not surds in the denominator. And so I guess that's the main reason. To be clear, that a fraction with a rational denominator is not simpler. So in terms of making sure that you give your answer in simplest form, you do not need to rationalize the denominator. You just need to make sure your surds are in simplest form and your fractions are in simplest form. However, a question might specify that you should give the answer with a rational denominator, in which case then you need to know how to do it. Also, you just need to be aware, for example, that two things that look a bit different, they might actually be the same thing. One just has a rational denominator and one doesn't. So the key thing here is we know how to work with fractions. We know we can create other equivalent fractions by multiplying the numerator and denominator by the same thing. So for example, I know that, 3 on 2, if I multiply the top and the bottom by root 2, that's the same as 3 root 2 on 2 root 2, that they're the same fraction. Now obviously that's pretty cumbersome. You would simplify that to 3 root 2. But I guess the point is if this was 3 on root 2, well then when we multiply the top and the bottom by root 2, on the denominator, root 2 times root 2 is just 2. And now we've got this nice fraction without a surd in the denominator, i.e. with a rational denominator. And so that's the idea of what we want to do here. So we want to be able to think about, well, what do I need to, we know equivalent fractions are found by multiplying the top and the bottom of the fraction by the same thing. So what can I multiply a surd by to make it not a surd anymore? Okay, and so if I've got root 2, I know that if I take root 2 and I multiply it by root 2, it's going to be 2. So when I multiply a surd by itself, it's no longer a surd. It becomes rational. So that's the key. The other key is that it's not just about, I'm not just squaring the denominator. I am kind of, but I don't have to do that. So in terms of what could I multiply 5 root 3 by to make it rational? Now lots of students make life harder for themselves by multiplying this by 5 root 3. Now 5's not the issue. 5's not irrational. I don't need to multiply by 5. I just need to multiply by root 3 to deal with the surd problem. Okay, 5 root 3 times root 3 is 5 times 3, which is 15, and that's a rational number. So it's not about multiplying by the whole denominator, it's just about multiplying by what you need to make the thing rational, okay? And whilst, yes, 5 root 3 times 5 root 3 is also a rational number, what happens is you introduce a common factor into your fraction that then requires that down the track you have to simplify the fraction. You're working with unnecessarily large numbers, which also means that you might make mistakes. There's all sorts of reasons to avoid it. So it's really just you have to multiply by the surd to get rid of the surd. So express each of the following in simplest form with a rational denominator. Okay, so I want to be careful about the language you use here. So we want to multiply, to make the denominator rational, we're going to need to multiply the denominator by root 10. So we have to do the same to the numerator. I want to be clear about the fact that you are not multiplying this fraction by root 10. You are multiplying this fraction by 1, which is why it doesn't change, which is why it's an equivalent fraction. You are multiplying the numerator and the denominator by the same thing. You are always multiplying by 1. In this case, we're going to write that 1 as root 10 on root 10 because that enables us to get rid of the surds, okay? But you're not multiplying by root 10, okay? If you took 1 on root 10 and you multiplied it by root 10, you get root 10 on 10 and you get 1. That's not the same as that. We're not trying to create something different. We are trying to create an equivalent fraction. So always multiplying by 1 and that is we're multiplying the numerator and the denominator by the same thing. So we multiply top and bottom by root 10, that is we're multiplying the whole fraction by root 10 on root 10, which is 1. So on the numerator we've got one lot of root 10, which is root 10. On the denominator we've got root 10 times root 10, which is 10. So 1 on root 10 is the same as root 10 on 10. The advantage of the latter is that it has a rational denominator. So then if I was trying to add it together with a fifth, for example, easier to find the common denominator. Okay, 5 on root 7. Okay, so it's all about what do I have to multiply the denominator by to make it rational? That would be root 7. I must do the same to the numerator. So again, I'm still just multiplying by 1, but this time that 1 is written as root 7 on root 7. So numerator, 5 times root 7. Denominator is root 7 times root 7, which is 7. So 5 on root 7 is the same as 5 root 7 on 7 with a rational denominator. Okay, example 3. So this one looks a bit tricky because, well, hang on, the denominator is just 2, but this whole thing's under a surd. We want to be able to think about this as the same as root 5 on root 2. So in this form, it doesn't have a rational denominator. So I'm going to need to multiply the denominator by root 2, and so I need to do the same to the numerator. So I'm, again, not multiplying by root 2, I'm multiplying by 1. So be careful what you write. I don't want you to write times root 2, because it's not what you're doing. You're multiplying by root 2 over root 2. On the numerator, root 5 times root 2 is root 10, and on the denominator, root 2 times root 2 is 2. Now, root 10 divided by 2 is not root 5, okay? Root 10 divided by root 2 would be square root of 10 on 2, which would be square root of 5. But root 10 divided by 2, in the same way that 2 times root 10 is not root 20, these are separate things. You've got a non-surd and a surd. We just write them. You could think about this as the same as half root 10, okay? That half doesn't go into the surd. Okay, question 4, we want to rationalize the denominator again. So, okay, we've got binomial expression on the numerator, 2 terms on the numerator, that's okay. Still focusing on, we're rationalizing the denominator. What do we need to multiply the denominator by to make it rational? In this case, we're going to multiply it by root 3. Just realised, oh good, sorry, I just thought I didn't include any harder examples. And so we're going to do the same to the numerator. So again, we're not multiplying by root 3, we're multiplying by 1 always, but in this case the 1 is in the form root 3 on root 3. So the numerator, we're going to have root 3 times 3 minus root 5 over root 3 times 3, which is 3. Let's expand out those brackets. Root 3 times 3 is 3 root 3, minus root 3 times root 5 is root 15. And you might do that straight away, all over 3. My surds remaining in my answer are both in simplest form, and so we're all good. You can split this up. Please be careful about this. They don't cancel. If you really want to, you could write this as 3 root 3 on 3 minus root 15 on 3, and then in this fraction only, the 3's cancel. So it's the same as root 3 minus root 15 over 3. Okay, that is the same as that. Both are just as simple as each other. One has a common denominator, one has 2 separate terms. But please, let's not do that. 3 is not a common factor with the whole numerator. Remember, you have to be able to divide the whole numerator by 3, and if you can't, then your fraction is in simplest form. Okay, example 5, we've got 1 on root 5 plus root 5. So one of the main reasons for rationalising is to make it easier to work with multiple terms combined together, find common denominators. So we could find a common denominator of root 5 and then combine them together, but given that the question specifies I want to express my final answer with a rational denominator, I'm going to rationalise first and then worry about combining these things together. Okay, so let's just focus on, we obviously don't need to rationalise anything here. The denominator is 1, which is rational. There's no problem there. But let's focus on that first fraction. So I'm going to multiply at the top and the bottom by root 5. And then we've still obviously got our root 5 over there. So this is where we're just focusing on that. That is just that, still just sitting there waiting for later. Okay, so we've got 1 times root 5 on the numerator, which is root 5 on root 5 times 5, root 5, which is 5, plus root 5 over 1. So these are like terms, so we do want to combine those together. So we need a common denominator to be able to combine those together now that we've got our fraction rationalised. Common denominator is 5, so we'll leave this one as root 5 on 5. This is going to be 5 root 5 on 5. So we've got 1 root 5 on 5 plus 5 root 5 on 5. So 1 plus 5 is 6 lots of root 5 on 5. Okay. You could always think about this in different ways. You know, essentially what we've got here is we're saying we've got root 5 on 5 plus root 5. You could take out the root 5 as a common factor, so it's a fifth plus 1, which is where the 6/5 comes from. So it's 6/5 times root 5. Okay, so a few different ways to think about it. But rationalise, common denominator, put them together, make sure at the end of the day that your fraction is in simplest form, so 6/5 is all good, and that your surd is in simplest form, so root 5 is all good. Okay, example 6, so we've got surds in the denominator of both fractions here. Let's focus on rationalising those denominators. I'm going to just try and do it in one step here. The first fraction I'm going to multiply top and bottom by root 6, so that's going to be 5 root 6 over 6. And the second fraction I'm going to multiply top and bottom by root 3, so that's 7 root 3 on 3. Now that I've got rational denominators, it's easier to find a common denominator. 6 is the common denominator, so I'm going to leave the first fraction as it is. We need to double the top and the bottom of the second fraction, so 14 root 3 on 6. And now we don't have like surds, so just 5 root 6 minus 14 root 3 all over 6. So given that they're not like surds, actually that and that, they are both as simple as each other. Whereas here, we couldn't just stop at this point. We did need to combine them together because they were like surds. So you could leave it as two separate fractions, or you could combine it together into the one fraction. Both of these answers are fine. Okay. All right, question 7. Let's get into those bit more complex denominators. So like this second example we talked about up here. So here we've got a denominator of 2 root 5. Now the temptation here, I don't want you to write this down. Let me show you what lots of students will do and what lots of you will do. You'll go, oh, I multiplied the denominator by 2 root 5. That's how I make it rational. And so then in the numerator you've got 2 root 5, one lot of 2 root 5. And in the denominator you've got 2 times 2, which is 4, root 5 times root 5, which is 5. And so you've got 2 root 5 on 20. And then, oh, hang on, my fraction's not in simplest form. 2 is a common factor, so it's root 5 on 10. Now that common factor of 2, you unnecessarily introduced that there. You don't need 2 root to multiply top and bottom by 2 root 5. You just multiply top and bottom by root 5, and straight away you get to root 5 over 2 times 5, which is root 5 over 10. Okay, so it's not about multiplying by the denominator by itself. It is what do I need to multiply the denominator by to make it rational. I just need to multiply it by root 5. 2 is already rational. There's no need to multiply by 2 again. So the numerator is 1 times root 5, which is root 5. The denominator is 2 times root 5 times root 5, so that's 2 times 5. And so we get root 5 over 10 is our rational denominator. Alright, again, part 8, we don't need to multiply top and bottom by 2 root 3. We only need to rationalise, which means just multiplying by root 3. So when we do that, the numerator is going to become 7 root 2 times root 3, so that's 7 root 6, and the denominator is 2, now root 3 times root 3 is just 3. So we've got 7 root 6 over 6. Fractions in simplest form, surds in simplest form, everything's good. Okay, question 9. Again, we want to multiply top and bottom by, focusing on what makes this rational. We'll multiply by root 2, do the same to the numerator. So on the numerator we have root 2 times 4 root 3 plus 2, and on the denominator we're going to have 5 times root 2 times root 2 is 2. Let's expand out the numerator. 4 times root 6 plus 2 times root 2 all over 5 times 2, which is 10. Now in this case we don't have our fraction is not in simplest form. We can't combine together those surds. Both surds are in simplest form, but there's a common factor of 2 everywhere here. So we can take out a factor of 2, that's 2 root 6 plus root 2 over 10, which means we can divide the top and the bottom by 2 to get 2 root 6 plus root 2 over 5. Okay, you can get straight from here to here without writing the factorising line by dividing all the terms by 2. Okay, but I encourage you still, while your fraction knowledge is a little shaky for some of you, to really understand that you need to factorise before you can identify any common factors. So taking out that common factor of 2, and then we can simplify our fraction. Okay, last example here, 10. Okay, we want to subtract 2 fractions. They don't have common denominators. One's got a surd, one doesn't in the denominator. So let's focus on rationalising the denominators first, and then we can focus on the common denominators in the subtraction. So we don't need to do anything with the first fraction for now. It's already got a rational denominator. The second fraction, we're going to multiply the top and the bottom of that by root 5. Okay, so again, we're not multiplying by root 5, we're multiplying by 1, so we're not changing the value of anything here. It's just allowing us to write with a rational denominator. So 2 root 3 over 5 minus, now the rationalising here in the second term, root 6 times root 5 on the numerator, so that's root 30 over 3 times root 5 times root 5, so that's 3 times 5, which is 15. Okay, now we get a common denominator, which will be 15. So the first fraction, to make that denominator 15, we need to multiply by 3. So we multiply both the numerator and the denominator by 3, so that we're only multiplying by 1. So we get 6 root 3 minus over 15 minus root 30 over 15. We've got that common denominator, so we can combine them together. 6 root 3 minus root 30 all over 15. Okay, making sure our fraction is in simplest form. So this is 1 and 6. There's no common factors between 1 and 6. And so we won't be able to cancel anything down with the denominator. Root 30 is in simplest form. There are no square numbers that go into 30. 4, 9, 16, 25, none of them go into 30. And so we can't simplify our surd or our fractions any further. Okay, so exercise 6D gives you some practice of rationalising the denominator. This is part 1 of rationalising the denominator. In the next video we will look at more complex denominators and how we rationalise those. Actually, just before we finish up here, I wanted to just have a quick chat about the CAS. So as we know, there's no special instructions in your CAS to simplify, okay? If you type something into your CAS that's not simplified, it will simplify it. So if I type into my CAS, let's just go back to this example 1 on root 10, my CAS will always, all I did there was press enter, it will always give the answers in simplest form and with rational denominators. So there's no special instruction to tell it to rationalise the denominator, that's what it will do. So if we have a look at example 2, if we type in 5 over root 7 and press enter, it's 5 root 7 on 7. Okay. If we take one of these more complicated examples, let's see what it does with example 5, because we might need to ask it to do something else here. Let me just see what it does. 1 on root 5, because we've just got the two terms, plus root 5. Yep, 6 root 5 on 5. However, example 6, I suspect, let me type that in, control divide for the fraction. So 5 on root 6 minus, let's see what we get, 7 on root 3. No, all good. Now it has done some uglier factorisation. The CAS loves to factorise when factorisation is not necessary. It is the same thing. If we were to expand out that bracket on the numerator in the CAS screenshot, you'd get 5 times root 6 minus 14 times root 3. And it is not at all necessary to factorise that numerator in the way that they have done. So you might get something that looks slightly different, but the important thing is that it's going to have a rational denominator. Same with, these more complicated denominators. Let's have a look at question 8. So 7 root 2 over 2 times root 3, 7 root 6 on 6. Okay, so no need to instruct your CAS to simplify. When you press enter, that's exactly what it will do.